So remember that my goal is that you're well prepared for algebra next year. And one of the things I've noticed that my students struggle with this year is this idea of subtraction and negative. So I'll have students ask me, Ms. Johnson, is this 5 minus 2 or is this a negative 2? And I tell them it's the same thing. So I can write this expression as 5 minus 2 or 5 plus a negative 2, and they yield the same answer. So 5 minus 2 is equal to 3. 5 plus negative 2 is also equal to 3, and I want to show that on the number line. So if I have, if I start at 5 and I subtract 2, so I'm going to go back 1, 2. This is minus 2. I end up at 3. Similarly, and I'm going to show this with some different colors. If I go plus 5, so now I'm at 5, and I add a negative 2. So I'm going to represent that as adding negative 2. So this line is negative 2. So I'm adding a negative 2. I end up at 3. So it's, you can think of it as the same expression. I'm just writing it as addition. So I can go back and forth. And I want you to be able to do that fluidly. I don't even want you to see this as anything different. You can write it as 5 minus 2, or you can write it as 5 plus negative 2. Same thing. Okay? So in your problems, your first problem is asking you to rewrite each expression as an addition problem and then show that the two expressions are equivalent. So the example is 4 minus 3, and we can rewrite that as 4 plus negative 3. And when you show that they're equivalent, all you're doing is going ahead and simplifying this. So 4 minus 3 is equal to 1. 4 plus negative 3 is equal to 1. You're going to do that for problems 1 through 5. Then when you get to, let me do a new one. Then when you get to problem 6, now we're introducing some variables, but it's the same activity. 4x minus 2x can be rewritten as 4x minus 2x. These are the same. And let's show. If I have 4x variables, right? And I'm taking away 2 x's, right? So let's take away 2 of those. Then I'm left with 2x. Okay, so this is equal to 2x. Now, we've seen this before in some of our problems. If I have 4x and then I have 2 negative x's, and I'm adding those together, well, the x and the negative x cancel out, another x and a negative x cancel out, and I'm left with 2x. So it doesn't matter how I write these. It yields the same answer, but I want you to see that this is equivalent. 4x minus 2x is the same as 4x plus negative 2x. I'm just writing them somewhat differently. Okay, once you get to the distribution, and there's a couple notes that I want you to take. So when we look at distribution, this is really a way to write things in a shorter way, I guess. So if I had something like 2 plus 4, okay, I could write this as 2 times 1 plus 2 times 2, right? 2 times 1 is 2. This is equal to 6. This is equal to 6. Okay, well, I notice that I have 2's in both of these, right? multiplying 2 times 1, and I'm multiplying 2 times 2. What if I took out that 2? It's common, right? So I'm multiplying 2 times both 1 and 2. Now let's see if this is equivalent. 1 plus 2 is 3. 2 times 3 is 6. So when we think about distribution, it's another way of rewriting an expression. And mathematicians do it because this is sometimes easier to write than this longer expression. Now let's look at some of the problems. If I have 3 times 1 plus 4, okay. Order of operations tells me what? Okay, let's think about order of operations. We have grouping symbols. Those come first. So those can be our parentheses, our braces, our brackets. Okay. Then we have exponents. Okay, so anything that has an exponent, like 3 squared, we would do that next. Then we have multiplication and division, same step. And then we'll have addition and subtraction. This is our order that we simplify expressions. So here, I would, before I multiply, I need to do my grouping symbols. Okay, so 1 plus 4 is 5. I still have this 3 on the outside. 3 on the outside, anything on the outside of our parentheses means multiply. So I would want to multiply 3 times 5, and that is equal to 15. Good. But we can also rewrite this. When I distribute, what I'm doing is I'm saying I'm going to multiply each term in my parentheses by this number on the outside. So I'd multiply 3 times 1 plus 3 times 4. Okay, so 3 times 1 plus, and I'm getting that plus from here, 3 times 4. Now, order of operations tells me that I need to multiply before I add. So 3 times 1 is 3. 3 times 4 is 12. Bring down the plus, and now I can add. 3 plus 12 is equal to 15. Notice, answers are the same here. So when I look at my problems, the first one is 3 times 2 plus 4. And we're asked to show that the expressions are equivalent, that is the same as 3 times 2 plus 3 times 4. Okay, so let's check this out. Order of operations tells me that I need to do parentheses first. So 2 plus 4 is equal to 6. I'm left, remember this is multiplying outside of these parentheses, so 3 times 6. I do that next, that's equal to 18. Now let's see, is that the same as 3 times 2 plus 3 times 4? Let's see. Remember, before we add, we have to multiply. 3 times 2 is 6. 3 times 4 is 12. Then I can add those together, and this is equal to 18. So this is what I want you to show, that these are equivalent. When you get to number 2, I have 3 different expressions. I want you to see that all of these are equivalent. So let's start here. Order of operations has parentheses first. 3 minus 1 is 2. I multiply that by 4. 4 times 2 is equal to 8. Now let's go to this next one. Our distribution would say 4 times 3 times, or minus 4 times 1. We're going to keep this symbol here. 4 times 3 is 12. 4 times 1 is 4. Bring down this subtraction. Now 12 minus 4 is equal to 8. Okay, so 8 equal to 8. But I can also rewrite this. We just talked about rewriting this subtraction as addition of a negative, right? So that's where this negative 1 comes in. 4 times 3 is 12. 4 times negative 1 is negative 4. Bring down the plus. 12 plus negative 4 is 8. So all 3 of these expressions are equivalent.